Hi friends, welcome to this channel again. Today we'll be solving one more question related to signal and system, and the question is a system with input x of t and output y of t can be described by w dot of t equals y of t plus x of t and y dot of t equals minus w of t. The impulse response of this system is, so these are the four options, and from there we need to find what is the impulse response of the system. So what we can do first is we can see here what actually he's trying to ask. So this is a system in which x of t is the input and y of t is the output. Okay, now this x of t has to be del of t in case of impulse response. This thing we know. Okay, this is the input. So what you see here is an extra variable which is w of t. If we are able to remove this w of t, then the relation between x of t and y of t can be formed, and once that is formed we can substitute x of t equals to del of t and get the result for y of t, and that will be our answer. Okay, so first what we do is the first thing what we do is we write the two equation and we try to find whether we can have a relation between y of t and x of t, and we are able to eliminate w dot of t. So w dot of t from the first equation is y of t plus x of t. Okay, and from the second equation you have y dot of t equals minus w of t. So you can see here that if I differentiate this equation once, then I get w dot of t because it will be differentiated once. So w of t will be w dot of t after differentiation, and once that is done I can substitute it from here, w dot of t, the value of w dot of t, and I can get rid of w of t. Okay, so let's do that. Let's differentiate this equation. I'll name it as 1, and the above equation I name it as 2. Okay, so let's differentiate 1. So what we get is differentiating we get is y double dot of t equal to minus w dot of t. Okay, now from 2 putting your my w dot of t. Okay, putting value of w dot of t. So now when you put the value from equation 2 into the equation which we have differentiated, what we get is y double dot of t equals, okay, minus y of t plus x of t. Okay, now what you can do here, you can see only x and y terms are there. Now you can see only x and y terms are there. So now once we are only having y and x terms, so what we can do, we can take y terms to one side and the x terms to the other side. So what we do is y dot of t, okay, plus y of t equals minus x of t. Now what we can do is we can substitute x of t equals to del of t because we need to find the impulse response. So impulse response means we have to substitute it with the del of t. Okay, so once we do that, the impulse function, so what we get is y dot of t plus y of t equals minus del dot of t. Now we can solve it in many ways. So the easiest way is to take Laplace. Taking Laplace, okay, of the equation. So when you take the Laplace both the sides, what you get is, this is using the differentiation property of the Laplace. This y double dot of t will go to s square y of s, okay, plus y of t will go to y of s. Okay, and we know that the Laplace of del of t is 1, so here we get is minus 1. Now you can see it's like an algebraic equation. So what you do is you take y of s common and you get 1 plus s square equals minus 1. Okay, so from here you get y of s is equal to minus 1 over 1 plus s square. Now we need the answer in time domain. So what we do, it we take the Laplace of this. So we know that Laplace of 1 over 1 plus s square is equal to sine of t, okay, sine of t u of t, okay. So this is the Laplace of 1 over 1 plus s square. So again, taking Laplace L inverse, I will say L inverse. So we get y of t equals minus sine t u of t, okay. So from here we can see this is the answer, okay. So it matches with option B. So option B is the correct answer for this question. So this is how we need to proceed for problems like this. And thanks for watching.